All right, so we are solving another problem from JEE Main 2019. In this question, uh, it's asked that we have to find the locus of the midpoint of a line PQ, and where the line PQ is actually made using this condition that a tangent to the circle is drawn, and that tangent is intersecting the coordinate axis at certain points P and Q. So we had to find the locus of the midpoint of PQ. So this is a very straightforward question in that regard that the circle is very, very simple. So if you look at, mm so we've got a circle mm, which is having its center at origin. So we can just take a smaller circle here. So the center of this is at origin, and there is a tangent which is drawn to it, which could be cutting the, basically, this will be touching this and then intersecting the coordinate axis. So these are the points P and Q. So this is your point P and this is point Q. So we have to find the midpoint, the locus of the midpoint. So whenever a circle like this is given x square plus y square equals to 1, then it's easier to take the point on the circle in a parametric form. So our parametric form is generally r cos theta, r sin theta. When we do that, then there is one less equation to solve. Otherwise, we'll have to solve one more equation. So in this case, r is 1. So this point is going to be cos theta and sin theta. And then what we can have is the equation of the tangent will be basically x1 plus y1 equals to 1. And then you can just substitute. So this will become x cos theta plus y sin theta equals to 1. Now, this is an equation of the circle, and if it is intersecting your coordinate axis here and here, right? So point P's x coordinate and y and Q's y coordinate we need to find out, because x coordinate of point P is something, but y coordinate will be 0. So to find out the x coordinate of point P, we can substitute y equals to 0 here. So substituting y equals to 0, we get x equals to 1 by cos theta. And similarly, if I substitute, so my point P is actually come out to be 1 by cos theta, comma 0. Similarly, if I have to find out point Q, then I have to substitute x equals to 0. So when x is 0, what will happen? Y would become 1 by sin theta. So it means that point Q is actually going to be 0 and 1 by sin theta. Now, what we're supposed to find out the midpoint of line segment PQ. So that could be anywhere, we don't know, here and anywhere. And then this is what we're calling as the midpoint. And the coordinate of that is actually h comma k. So h would be actually equal to x1 plus x2 by 2. So x1 plus x2 by 2, that will be my x coordinate. And y would be y1 plus y2 by 2. So in this case, x1 plus x2 by 2 is going to be equal to 1 by cos theta plus 0 by 2. And similarly, k is going to be equal to 0 plus 1 by sin theta by 2. So from here, what we get? We get 2h equals to 1 by cos theta, or cos theta equals to 1 by 2h. From here, we get sin theta equals to similarly 1 by 2k. Now we also know a trigonometric identity that sin square theta plus cos square theta equals to 1. Right? So once we write that, then we will get rid of theta. So this will become 1 by 2h whole squared plus 1 by 2k whole squared. And this will be actually equal to 1. So this will become 1 by 4h square, and this will, oh come on, and this will become 1 by 4k square. And then what we can do is we can take LCM of 4k square h square, and then we can have k square plus h square here. So finally, what we will have is h square plus k square equals to 4k square h square, or h square plus k square minus 4k square h square equals to 1. Now, this is what the equation is. Now I can substitute back h equals to x and k equals to y. So this is what will be my equation. X square plus y square minus, this will be actually 0, sorry. If it comes this side, 4x square y square equals to 0. So this is what will be my locus of the midpoint of line segment PQ. And if you see, there will be one of those options which is given to us. So this is actually, this is the option, x square plus y square plus 4x square y square. This is what it is. Okay. So it's not that you cannot take any other point. You could also solve it using a generic point x1, y1. But then when you want to get rid of x1, y1, you have to substitute it back in this equation, because this will be also satisfying the circus equation. So it's always easier to take the parametric form of the point actually, and then actually work with it. So yeah, that is how it will be done. I mean, all I'm saying that you can do it in other ways as well, but this is a simpler method to do. Okay, so that's all for today. Thank you for watching this video. If you have any questions, please do ask me in the comment section below, and I'll be really happy to answer your queries. Thank you so much for watching this video.